Hey guys, this is Mitch with Fine.CGI, and today we're going to talk about how to secure your data in transit using secure WebSockets. So we're going to go through the process of generating a certificate, talking about how it works. We're going to go through and talk about why it's important and what it's doing and how it operates. And then we're going to talk about how to generate your own certificate and self-signed certificates and the advantages and disadvantages of that. And then we're going to go in and actually set up our code so that we actually have a secure transport layer or a TLS for our game so that our data can be encrypted during transit between our client and our server. We also talk about how to use WireShark to sniff our packets and determine how secure our stuff actually is. And then finally, we talk a little bit about SSL certificates and how to get a hold of them. So that's what I have in store for you guys today. So let's go ahead and get started. All right. So first, let's talk about some prerequisites. You'll notice that my scene is actually already populated with some stuff. You can see right here. Now, the reason why this is because I'm actually continuing another tutorial that I previously did, and that is my WebRTC tutorial series. So if you haven't taken a look at that, go ahead and take a look at it, pause this video, go back to that, and then do that. Now, that being said, if you already have a WebRTC setup or you already have your networking all set up and done, then you can definitely follow along with this tutorial. It's mostly self-contained, but it's not all self-contained. So that's just something to keep in mind. Now, if you just want to learn the concept, you could just go down to the link in the description below and you could pull down this project and then go ahead and follow along from there as well. So I have lots of options here that you guys can go ahead and do this tutorial. So with that being said, now let's answer the next big question. Why are we doing this, right? What is the purpose of making your stuff secure, right? What is the purpose of encrypting your data in transit? And how does it work? Well, the reason why we're doing this is because if we go ahead and we take a look at some of my code in, I believe it is this one, which is my finished product. If I come in here and I hide under here and I pull out my TLS setup here like so, and I come into my server and I pull out my X509 cert like so, if I hit play and I run this, and then I come into WireShark, and I'll explain what WireShark is in a minute. So if I click Start Server, and then I click Start Client, you'll notice that I get packets, right? If I click on this, you can see that I can see all different bits of information and things like that with this. You can see HTTP, switching protocol, WebSocket connection, right? If I go and I log in, so this create user actually logs in my user. This is for a future WebRTC tutorial, which we'll be talking about how to create a login system. But if I click on this, you'll see that some more packets come through. Now, if I click right here, this is a WebSocket binary data. And you can see right here, I can actually see the data. ID 1, losses 0, message 1, peer ID is this. And our rating is 1000 and our score is 10. So you can see here that you can actually pull back a lot of that information right here. And the part that's problematic is you can pull back user information by doing this, right? So if you were passing in passwords, like for instance, let's say I was passing password data across the network, people could just intercept that data and then actually see it right here, and they could steal it and then use it for their own purposes. And also it allows them to intercept that data, change it, and then send it along the pipe. And if I remember to do that, I'll show you guys how that's done and actually talk about it and why it's important. But if we take this data and we encrypt it, and I'll show you how that works. But if we take this data and we encrypt this data, so let me undo what I did. So we'll come in here, change this to our WebSocket connection. We refresh this and we start our server, we start our client, and then we log in. You'll see we get our message right here that says our user has logged in right here. And then if we take a look at our message data, when I scroll all the way to the bottom and I click on that application data, this is what it looks like. So it's completely encrypted and it's impossible to see what that data is. And that's the beauty of encryption. And that is why I'm creating this tutorial, is to go through how to actually achieve this. So that's the purpose, and that's why you want to do it, is it makes your game more secure. It makes it so that the data that gets sent across the wire is not sniffed. So if there's any security information, it's not going to get shown. And finally, it stops them from being able to sniff your packets and change the data, because that can really mess with the game and can make the game a bit less hacker prone, if that makes sense. All right, so it's really cool to know that it works, but how does it work? Now, if you don't care about how this works and you just want to get to the tutorial, just jump to the next time code and that's totally fine. But how does this actually operate? So basically, the way that encryption works inside of Godot is by using TLS encryption. This is also known as SSL. It's basically a tool that is used to secure communication over basically all of the internet. Most of the internet actually uses this system. So how it works, it creates kind of like a safe tunnel between two different groups or two different computers. So you have your server and your client, and it basically creates this little secure connection between the two. So the question is how does this work? Well, first, the client initiates this handshake. It basically says, hey, I'm a client. I want to talk to you, the server. And then the game server says, okay, cool, right? It'll actually pass a public key to the client, and then the client will have this public key here. Let's take a quick step back. So basically, to get a hold of a key like this, it comes from a certificate authority. Somebody who is a well-known, trusted person creates a key and says, this is a valid key for this game server. The game server has this certificate, which has a public and private key. The client says, hey, I want to talk to this game server. It says, hey, great, here is a public key from a certificate authority. The client will come to the certificate authority and say, is this a valid certificate? Is this a valid key? And the certificate authority will say, yep, I'm okay with this. We're good to go. And then at that point, the group decides to basically communicate, right? So what they do is, using this public key, they pass a secret across the wire to the game server. The game server then basically negotiates an encryption algorithm between the two of these guys, and it sets up that encryption. And then every single time a message gets sent across the wire, so assume that we have a message with data test, right? And then let's say, password, right? What it will do is it'll take this, it'll encrypt it with the private key that this guy has. It'll become a mess of gobbledygook. So it just literally becomes just like a mess of binary data effectively. It sends it to the client. The client takes the public key and then decrypts that data and says that this is this data, and then it uses the data. So it basically encrypts the data in translation. And that's effectively how this operates. So now that we have a basic understanding of how this operates, how does it work inside of Godot? Well, thankfully, inside of Godot, it's relatively simple. So if we open up Godot here, all we have to do is create a certificate and then point our server to that certificate. Now, we have two major options to handle that. We could use PuTTY to generate it, or if you don't want to use PuTTY, you can use Godot to generate it. It actually has some code to handle that. That being said, typically you don't want to use Godot to generate your certificate just because it's not necessarily useful. So I'll leave a link to PuTTY, but basically with PuTTY, all you have to do is click generate. You add randomness like this, and it'll generate out a random RSA 2048 key. And then you can save a public key like this, and then save it somewhere, and then save your private key as well. And there you go. Now on Godot's end, if you want to do it the Godot method, all you have to do is open up your scene, specifically that we've been using. So in our case, it's the control.tscn, which I should probably rename demo scene. So I'm going to do that real quick. So that way it actually matches with what we typically use. And on the start server side, I'm just going to duplicate this button here. I'm going to pull this back and drag my start server to over here. And I'm just going to call it generate certificate like that. Now, you don't want to expose generating certificates to the users. This is just for this demo. Generate your certificate, put it somewhere safe, and then use it in production later. Don't go and give anyone the option to do this. And don't generate certificates at runtime. It's not worth it. Just generate one certificate and go from there. Now, to generate a certificate, all we have to do is go into our node, right-click, disconnect, double-click on our button down, go to server, and say on generate certificate, button down. To generate a certificate, it's relatively simple. All we have to do is come in here and use the Godot cryptography class. So we'll say var crypto is equal to crypto.new, like that. And then we need to create a key. So we'll say var key crypto key.new. And then we'll say var cert is equal to x509 certificate.new. And when you hear the term x509, just think of a certificate. It's basically just a key to encrypt your data. It's a certificate that says that this is valid, right? That's all it's for, basically. It's just to say this is a valid key that can be used to encrypt data. And then all we have to do is say key is equal to crypto.generate RSA, and we'll pass in 4096, and that's going to be the length of our key. The longer the key, the harder it is to decrypt. Now, of course, 4096 is obscenely large, and it's really, I have never needed to use a larger key size than this. And now we got to generate our certificate. So we'll say cert is equal to crypto.generate self-signed cert, and we'll pass in our key, comma, and then we need to pass in some information. So you'll see that it has some CNO. If I pop this guy out real quick for you, you'll see that we have CNOC, not before, not after, right? Now, for the most part, you're not going to use the last two options here, but for the issuer name, you will be using that. So we'll hit quote CN is equal to, and then you'll want to put some kind of organization. So fine.cgi.com, comma, and then you'll want to put some kind of organization. O, so organization is fine.cgi, because that's my company's name. And then you're going to want to add in a C. So it's kind of like a type of certificate. So C is equal to IT. And then from here, we basically can save out our key in our certificate. So we'll say key.save, and we'll pass in where we want to save that key. So res : and I will do server key.key. And then we'll say cert.save res : server cas.crt for our certificate. Now remember, a key is what encrypts the data. A certificate is what validates that that key is a valid key. So that's something to keep in mind. And then we could just basically play our game. So if we go in here, we can hit play and we can click generate certificate. And you'll notice that nothing really happened. Well, if we go out to RES and go to Open File Manager, you will see that there is a server.cas and a server.key right here. And that's our certificate and our key. So now all we have to do is basically put that in practice. So if we go to our script and we come into our start server right here, we hit enter, we can say var server cert is equal to load server CAS. And then we need to do the same thing for our key. So var server key is equal to load res server key, like that. And then we need to set up our server options. So when you look at create server and you hit comma, you'll notice that there's a bind address, right? And then there's a TLS server options. And that's where we put in our actual keys that we're using. So we'll hit quote star, comma, and then for the TLS options, we can either just pass in TLS options.server and then pass in our key. So we'll say server key, comma, server certificate, like that. And there we go. And now if we hit refresh and we run our project and we start our server, you'll notice our server has started. If we start our client and then we attempt to join our lobby, you'll notice that it fails. It says could not get status connection status, right? And the reason why is because if this is set up for TLS, nobody can connect to it unless they're using a certificate that is valid for the project. So you can't have unauthorized connections to your project. It requires them to have the same certificate as the server to be able to connect. And if we do debug, run multiple instances, and we run 2 instances, and we attempt to do a connection, so if we go start server, start client, and join lobby, you will see that it does not connect. So how do we get it to connect? Well, that's actually really easy. If we go to our client and we head over to our connect to server, you'll see first we're using WS. Now, WS works great when you're just playing a game locally, but when you want to secure your stuff, you need to use WebSocket Secure, which is another S. It's WSS, and that will allow you to actually use it. Now, if you just hit play and you run and you go, yep, this is good, I have WSS now, right? Well, no, because you can't do WSS without having your TLS encryption settings set up. So in order to do that, all we have to do is come in here, load our CAS. So var client CAS is equal to load server CAS. And then we can pass in a WSS, and then we can pass in our TLS information. So we'll just pass in our TLS options. And if we hit TLS options dot, you'll notice that there's 2 of them. There's client and there's client unsafe. So what's the difference between the 2? Well, client unsafe allows you to just pass in a trusted chain. So it allows you to pass in just the CAS that we have. So the client CAS. But if we come in here, and let me maximize this, and we do .client, it says a trusted chain X509 certificate, common name override string, right? The other one doesn't have that option. So what's the difference between the 2? Well, client unsafe only requires a non-signed certificate from a authority. So what we generated, right? Just the certificate that we generated. Whereas the client one requires it to be generated from an issuing authority. It will go out and check. So think of it like this. If we look at this diagram again, remember when we said the game server will send a certificate to the client. The client will say, hey, is this valid certificate authority? And the certificate authority will say yes or no. Well, that's basically the difference between these 2. This one, it will validate with a certificate authority. This one, it will not. Now, typically, in my experience, larger games use a valid certificate. Smaller games typically don't, because overall, the security measures don't need to be as strict. Typically, smaller games just do client unsafe because it's easier. But that doesn't mean it's the right way to do it. You should get a certificate from a valid certificate authority. And when you do, you just pass it in here, just like we did with my server CAS right here. We could basically take that certificate from the CERT authority and use that instead of using the one that we generated, and then use this version instead. But in our case, because it's not a valid certificate from an authoritative server, we have to do it unsafe. Now, if I close this and I come back to Godot, I hit start server, start client, and I join a lobby, and that should have worked, but it didn't. So I'm not sure what's going on here. So if we take a look at our client, you'll see here, we do 204. That's my external server. So we'll go 127.0.0.1, and that should solve that problem. So if we hit refresh, start server, start client, you'll see that we have connected successfully. And if we pull out that certificate like so, and we pull out our WSS and we refresh it and we attempt to do a connect. So start server, start client, you'll notice that we get an error that says that our TLS handshake has failed. So that stops people from actually accessing our server without a valid certificate. And that can help and go a long way when it comes to actually securing your code and making sure that your code is good and securing your data and making sure that user data is not getting leaked, if that makes sense. Now, if we re-add that though, and we refresh it, you'll see start server, start client, you'll see we get back our data as expected. So that's pretty much how we can actually encrypt our data. Now the question is, all right, so I have this all set up, but how do I know if my data is actually being encrypted? And that is where a tool called WireShark comes in. Now, WireShark is a gigantic tool that is used in so many different ways, from penetration security testing to application development. It's a huge tool that I use a lot in my daily life as an engineer. So if you have the time to learn it, please do. It's really, really worth learning. When it comes to our tutorial, all we need to do is just come down and download WireShark now, and then pick your different distributable. In my case, since I'm using Windows, I will download the Windows version. And then once you have it downloaded, all you have to do is come into your downloads and then grab your WireShark Portable PAF right here. Once you have that, you just double click on it. It will pop up and it will run you through the prompts. You just hit OK, next, install. And what it'll do is it will go through and install it into a directory on your downloads. Now, if you want to download and install this, the correct way, you can do that too, just by running through the installer itself. But I find that this way is really simple. Now, when you click Run WireShark Portable, it's going to pop up like this. Now, you may not see a Welcome to WireShark capture right here. What you might see is, hey, you need to have NPCap to actually see your adapter's information. So what we can do is come in to go out to NCAP and actually download and install that. So it's right here. You just click this guy, hit save, double click on it, run through the install prompt. It'll say, yep, it's already installed. Sure, I'll reinstall it though. And then we'll hit next like that. And it'll run through and it will install it. And my guess is that it's using WireShark. So we'll hit OK. Let's let it do that. So what this is going to do is it's going to install a NCAP driver, which basically allows you to sniff the packets locally on your machine. So it's really important to have this if you want to do any kind of packet sniffing. So we'll click next, we'll click finish, and then we'll reopen up WireShark. So we'll go to downloads, we'll go to WireShark Portable, we'll double click on WireShark Portable, and it will open up like this. Now you will see all sorts of information here. You'll see all the different adapters you have. So you can see I have an Ethernet adapter right here. If I were to click on this and run it, you would see packets flowing through from me listening to music or me uploading videos or something like that. You would see all that information right here. But in our case, we don't really care about that because we're using a 127 address, right? We're coming in here and we're actually doing 127.0.01, which is our local address. If this address is different, then we don't want to use the adapter for loopback traffic capture. We'd want to use something like Ethernet or Wi-Fi if you have a Wi-Fi adapter. But in this case, because we're using 127.0.0.1, which is our loopback adapter, we'll go ahead and go into that guy. Now you'll see there's all sorts of information here that's getting sent through this loopback adapter. At this point, we can actually test our stuff, right? But this is a lot of data to feed through, right? There's just so much stuff going on. How do I know what is my actual information that I'm looking for? Well, that is where this apply display filter comes in. So all we have to do is type tcp.port is equal to, like that, and then type in the IP address we care about, which in our case is 8915 space or udp.port equals 8915, enter. And you'll notice that that immediately clears all of our traffic. Now, why does it clear all of our traffic? That's because there's nothing going through our traffic on that port, because that is the port that our server is located. That's actually the port that this guy here is located. You can see right here, we tell it which port to be on. So all we have to do is come in, hit refresh, start our server, start our client, join a lobby, and you will see that we now have all sorts of packets to look at. And now you can see here how it works. So we come in here, we create a transition, we transmit our data, we hello, right? So we create a hello, we create a server hello, we pass our certificate, we do that key exchange, we say server hello is done, the client exchange is its key, they exchange a cipher, they encrypt their handshake, they change their, it looks like they actually changed their cipher, so they didn't agree on it. Then they created their handshake, and then they passed in that application data. So this is the data that has to do with Godot at this point. This is actually the information that we're passing back. You can see right here, this is that information right here. That's this stuff right here. And you can see we keep passing back some application data like that. Now, if we want to look at this unencrypted, all we have to do is come in here, shut off WebSocket connection, do this, do that, Control S, go to server, and do the same thing like that. We'll hit refresh, start server, start client, and then you will see here is the data from this new connection. So you can see right here, there's our ID message. If I join a lobby, you will see there's the lobby information and all the connection stuff. So that's basically how you use WireShark in a nutshell. Now, if you hit the stop button, that will stop the capture. If you hit this, that will reset it. So that will actually clear all of your logs right here. And if we want to see packets now at this point, we're going to need to regenerate them. So you can see if I click join lobby, it will regenerate that information. So if I hit clear, continue without saving, I close my project, I re-enable encryption like so, I go to my client, I change this like that, and I change it to WSS, and I hit play, I hit start server, start client, join lobby, I click on this guy, you will see that all of that data is now encrypted, and the user can no longer see that data, and that data is now secure. Now, the last thing that we have to talk about is how to get a certificate from an authoritative source. So in order to do that, you need to go to a certificate authority and pay them to actually issue a certificate. Now, there's some people like DigiCert, there's Cloudflare, and there's Let's Encrypt, and places like Namecheap offer you a way to get those SSL certs or those certificates that you need. Now, Let's Encrypt does it for free. I'm not really sure exactly how they do it, so that's something that I'll have to look at, but I do know that they have an option to do it for free. I don't know how long it's valid for, but I know that this might be a good option for most people for their games when they're starting out. And then you might want to graduate to something like Namecheap or DigiCert to get a better certificate. Now, at this point, you basically have the fundamental understanding of how to encrypt your data using TLS. So if you like this video, go ahead and hit that like button. Hey, you know, if you dislike this video, go ahead and hit that dislike button because I'm here to make content for you guys. This video was a viewer suggested video, so if you have any suggestions, please leave them in the comments below or jump on my GitHub. Link is in the description and you can go ahead and make suggestions right there. And hey, you know, if you have any questions or comments, leave them in the comments below or jump on my Discord. Link is in the description for that as well. And anybody there will be more than happy to help you out with any questions you might have. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.